doing the calibration of the pH meter for titration. First, you have to make sure that it's always hydrated because it needs to have selectivity when it's going for hydrogen ion detection. So what you do is you take it out of the water, rinse it off to make sure, gently blot it. Because if you rub it too hard, it will knock out calibration even more and damage the instrument. First, we'll go with the green solution. And just kind of gently swirl it to make sure it gets an even reading. And if you'll notice the pH meter, it's rising and eventually it will stabilize.
And once we get to a certain value, we have the meter, and rinse it, put it in the water, and put it back in the regular water.
And so now we want to calibrate it to measure acid. So we have a buffer solution of pH 4. So again, dry off the electrode. And place it into the buffer solution and swirl it. So just rinse it off again and place it back in the water. In between trials, you should store your probe in DI water because it needs to stay hydrated. When you're ready for your next trial, your next buffer, take it out. Blot it dry again, never rub. And now you can test your end of solution because it's calibrated. Swirl it and wait for the pH to stabilize on the meter.
The slope of the horizontal line is always going to be 0. So whatever gives you the,
Once it stabilizes, record it in your data table to all significant figures given from the meter. Take it out, rinse it, and place back in the, rinse it completely, and place back in the deionized water. Solids and liquids are not included in the equilibrium constant expression because solids and liquids together equal 1. Since they equal 1, it won't affect the overall K value, and thus do not need to be included. The molarity of solids and liquids remains constant throughout the reaction. When a strong acid is put in solution, its ions will completely dissociate, and so it is not in equilibrium. It goes from reactants all the way to products, and it doesn't go back. However, in weak acids, all the ions do not dissociate, so some of the original acid is left, and it's in an equilibrium situation. It is useful to know that strong acids completely dissociate because the concentration of the acid will be equal to the concentration of the H plus protons in the solution, and that way you can use it to find the pH. And to minimize the effect of a strong acid or a strong base into the solution, you can create a buffer solution to prevent the pH from changing dramatically from when there's an addition of some of that acid or base.